I'm Kevin Hu, the CEO of Metaplane, a data observability tool, and I'm really excited to give you my 10-minute billboard talk at Move Data with fellow data nerds about the 5 causes of data quality issues. And to start off, you might ask, hey, I get data quality issues all the time, and they're all a little bit different. What I would put on the billboard is, even though data quality is a pervasive problem that has many symptoms, there are actually few causes. But before we go into that, I want to say congratulations to you all. You're the new head of data at Wordle Industries. So instead of being acquired by the New York Times, Wordle Industries is going on a rampage of global expansion. So now you get to build data foundations to have Wordle in 6 letters and different languages and so on. And this is a very exciting role. And you get the opportunity to piece together the data stack of your dreams. Airbyte for ELT, of course, into a data warehouse like Snowflake, transformed using dbt, and let's say you're using reverse ETL to send it back into Salesforce, or you're using Looker on top of it, used by growth and executive teams. But inevitably, something happens. And what happens is the most popular form of data testing today, which is called EDT, or executive-driven testing. So you find out about a data issue when the head of marketing says, hey, data team, why does this revenue dashboard look weird? And even though we're all virtual, I can just imagine how many people are nodding their heads along with this, because this is how people usually find out about data quality issues. And I'm just going to skip ahead a little bit and say, I believe Tolstoy had this quote at the beginning of Anna Karenina, which is that all clean data is alike, but all messy data is messy in its own way. Well, we're going to talk about 5 causes, which are input errors, infrastructure errors, incorrect transformations, invalid assumptions, and ontological misalignment. We're going to unpack all of those over the course of the next few minutes. And as we go into that, let's establish some context, which is, what is data quality? Well, what are businesses, right? Businesses are organizations that increase revenue, reduce cost, and mitigate risk. And these businesses bring on data as an approximation of the real world to have better decisions, better execution, and better products and services in order to build that business value. So with these levers in mind, there are a couple of pockets of data use cases that we all know and love. The most popular one is decision support, the main vein of business intelligence. You have operational data, in-product data, and we define data quality as the degree to which data meets the needs of these use cases, or an internal standard that operationalizes these use cases. And with that context in mind, let's get into the first cause of data quality issues, which I will, let's have a hypothetical question, which is, why do doctors have bad handwriting? Well, one potential answer is that it's because doctors never have to read their own handwriting, right? Pharmacists do. So an input error is when the incoming data does not conform to your expectations. So let's imagine an account exec put in a negative value into a contract size field in Salesforce. And we've seen this before. And there's actually quite a few solutions that we can use to address this problem, pulled from a couple of different inspirational communities. One of them is the electronic health record community, where they've established practices as double entry. You have to put it in twice, input validation at the source, having secondary checks by another party, or in the case of the doctor, getting some feedback. Because if you put in garbage in, but you never experience the garbage out, I'm just going to keep putting the garbage in. So that's one type of data quality issue. The second type of data quality issue are infrastructure failures. So your systems themselves do not perform according to expectation. So let's say Salesforce is down, or you have an upstream sync delay. And there's a few solutions here as well. I present these solutions with the citations because I can't go into a lot of depth, but hopefully this kind of sparks some curiosity to learn more and more tabs opening in your browser. Infrastructure issues are quite well established in terms of how you can alleviate these problems. For example, redundancy and failover systems, having interrupts the moment you detect an issue, or having automated backfills, because we know that in data, when something goes wrong, you have to go back and fix it as well. You can't just cycle up and down. The third type of problem are incorrect transformations. So these are things that are actually our fault as we're writing SQL transformations or DBT models, where code doesn't have the intended effect. Now, maybe it does for some set of cases, but an edge case comes in, or perhaps the data changes and the business assumptions that you made have changed as well. So I've definitely merged those DBT PRs that caused fan outs because I assumed a primary key, but there was some duplication. And then all of a sudden, your metrics look extremely wonky. And the solutions here are mostly inspired by good software engineering practices, right? Having unit tests and regression tests on your code, but also having it on your data itself, because there's many silent data bugs where even though the code is running and your systems are up, that the data can still be incorrect. Fourth, invalid assumptions. And this touches a little bit on the previous cause of data quality issues, where some upstream dependency has changed in terms of the structure, the content, or the semantics. And the reason this is important is because data doesn't live in a silo, right? It's the result of a complex chain of transformations, so that either data comes from other data, or someone put it in, or a machine put it in at the very source, at the original source. So let's just take an example of an upstream backend engineering team that creates a Postgres migration that you replicate into Snowflake, and it gets propagated all the way down, but all of a sudden you have a Looker dashboard, or specifically a LookML field that requires this field that no longer exists or is renamed. So solutions here are really dynamic. Data contracts are very exciting right now. So that's like a techno-sociological solution that you can use to enforce constraints further up in the chain, having better CI/CD processes, code tests, and data tests similar to transformation issues. And the last cause of data quality issues is, it's not technical at all, actually. It's every single one of us has a different concept of either the definition of a metric, or even what is a metric, what are the entities within our organization. So to give an example, maybe the sales team has a definition of churn as when they update the status of an account within Salesforce, but the growth team could have a usage-based metric of churn where a customer hasn't been using your product for the past 30 days. So it's extremely important to get on the same page, because even if the data is correct, even if your infrastructure is up, if people don't have similar or at least consistent models of what means what and how it corresponds to your business, then the data doesn't meet the use case and therefore is low data quality. Some inspiration here is looking into the knowledge management, even library sciences and ontology research, where, I'll say this word only once, but building dictionaries or glossaries or reference models for your data. But even that is a result of ultimately talking with other people and communicating with them. What do you expect? How do you define this thing? So finally, to group this all together, one way that we like to think of it is that data quality issues fall on the spectrum of knowable and unknowable, controllable and uncontrollable. You can't prevent or eliminate everything. You should prevent and eliminate that which is under your control. For example, bad DBT PRs that are being merged, those are knowable and controllable by your team. Ones that are unknowable but controllable, for example, input errors for an upstream team. It'll take you effort, but it's possible to place constraints on those upstream people and systems. But ultimately, some things are not in your control, right? Either it's a third-party system that is delayed, or there's an API change from a vendor of data. And it's really up to you to identify, okay, what things can I eliminate versus what things should I focus on detecting early and mitigating. And that decision is ultimately based on what is the cause of this issue and where in the provenance of data does that sit. And with that, that's all I got. Remember, many different symptoms of data quality issues, a few different causes, and thinking about those causes in a systematic and structured way and getting inspiration from other communities can hopefully reduce the number and severity of those. And if you have any questions, please follow me on the socials, Twitter, Mastodon, LinkedIn, Kevin Z, NGWho, or just send me an email. I'd love to chat. Thank you.